Hello friends, my name is Dnyaneshwar. Today I deliver lecture on functional analysis, one of the subject of mathematics. So this is lecture for M.Sc students of mathematics which I am in third semester. So we start this first chapter of this course is Banach space. Okay. So before starting this, we have to recall some definition regarding this. So first definition of this is metric space. Okay, so metric space, what is the definition of matrix? So recall definition of metric space. Let x be any any non-empty set. Okay, x be any non-empty set, and we define d from x cross x to r, and we define d from x cross x to r. This is clearly a real value function. So when we say that d is a metric on x, so d said that metric on x if it satisfies following three conditions. D is said to be metric on x if it satisfies following three conditions. So condition first, distance between any two points of x is always greater than or equal to 0. By definition of distance is always non-negative. Okay, so distance between any two points of set x is greater than or equal to 0. Here two cases, either distance equal to 0 or greater than 0. So if distance, in this condition, if we take distance between any two points is equals to 0, that means if distance between any two points is 0, that means it is possible if and only if that two points must be equal. Okay, if any two points of the set are equal, then and then this possible, distance 0. Okay, if distance is 0 any two points, between any two points, then clearly these two points are equal. Okay, second condition is nothing but symmetry property. Okay, so a distance either measure from x to y or y to x must be equal. This is nothing but symmetry property. This is the second condition to being a metric. Okay, so last condition to being a metric is triangular inequality. Okay, so what triangular inequality said that distance between x and y is always less than or equal to distance between xz plus distance between zy. How? So for this, if we take any 3 points, this point from set x. Okay, for all x, y, z belongs to x. So we connect this. After connecting this, we get a triangle. Okay, this point x, y and z, we get triangle. So clearly this is the distance between x, y is less than or equal to sum of these two distances. That means distance between xz plus distance between zy. So triangular inequality says that this distance must be less than or equal to sum of these two sides distances. Okay, this is nothing but triangular inequality. So this triangular inequality satisfy, then all three conditions are clearly satisfied. Okay, these three conditions, when any matrix satisfy, any function satisfy, which is defined above, then that function is called metric on our set. Okay, so to understand clearly we have to take an example regarding this. Okay, so first example is, if we take x equal to r, if we take x equal to r, set of real number, and choose a metric d of xy equal to mod of x minus y. We have to show this d is a metric on r. How to show? So for this we have to first recall properties of mod. Here function is defined by mod, so we have to recall the properties of mod. So first property of mod is mod x always greater than or equal to 0. It is equal to 0, mod x equal to 0 if and only if x equal to 0. Okay, so this is the first property. Second property is mod of minus x equal to mod x, and third property is mod of x plus y is less equal mod of x plus mod y. So by using these three properties we can show D is metric on R. Okay, so let us prove this, let us show this. Okay, so first property, distance between x y, that is defined by mod of x minus y. And by property first, mod is always greater than or equal to 0, as well distance between x y is equal to x minus y is 0 if and only if by condition first x minus y equal to 0, that implies x equal to y. So condition first of being metric is satisfied. Okay, so second condition we have to show. Here for all x y z belongs to, for all x y belongs to R, our set is set of real number. Second property is distance between x y, that is nothing but mod of x minus y, that is equal to minus of y minus x. Okay, that is equal to y minus x. How? By property second of mod. So we get that is nothing but distance between y and x. So symmetry property is satisfy this metric, this function. So D is satisfy second condition. We have to, for all x y belongs to R. So we have to show the remaining condition, which is triangular inequality. So for this we take distance between x y, that is x minus y. Here we add and subtract z. Okay, here we add and subtract z. So what do we get? That is less than or equal to mod of x minus z plus mod of z minus y. How? By property third of mod. Okay, and that is nothing but distance between xz plus distance between zy. Okay, so we get distance between xy less than or equal to distance between xz plus distance between zy. We can simply so by using in this way we can show D is metric on R. Okay, D is on metric on R, and this metric is defined denoted by RU, and is said to be usual metric space. Okay, metric defined on R is said to be usual metric space. So this is the one of the simple example of metric space that we have seen. Okay, Next lecture we study the norm space, and after that we can study Banach space. Okay, so in this lecture it is enough to understand the definition of matrix space and the regarding the example of this matrix space. Next lecture we see remaining points. Okay, thank you.